In order to measure objects, we need to have a common reference frame. For example, if I tell you an object has a length of 30 samuels, you might ask, what is a samuel? How long is one samuel? Without a common reference frame, exact measurements will never work. A good example of this is the foot. The idea of using a foot to approximate length dates back as far as the ancient Egyptians. Over the many generations after that, the exact length of a foot varied from area to area from time to time, depending on whose foot we use as a standard. And this happened for centuries, until about a century ago, when we finally developed a standard length which we know today as 1 foot, separated into 12 inches. Now there are different units which are used to describe different things. For example, we have the degree, which measures temperature. We have the gallon, which measures volume, and we have the hour, which measures time. To measure more precisely, we divide each measurement into smaller units, such as 4 quarts in a gallon, or 60 minutes in an hour. But the number of smaller units in one larger unit always depended on how history created those measures. So they're not always a nice number, such as 1 mile is equal to 5,280 feet. For years, other units besides the foot were based on different parts of the body. For instance, the inch was approximately the length of from the knuckle to the tip of your thumb. A yard is roughly 1 arm length from center of your body to the tip of your fingers. Cubit would be from your elbow to the tip of your fingers, so on. You can see the idea. There were lots and lots of units based on the human body. But recently we developed what's called the metric system. The metric system was created to simplify not only the standard unit, but also the conversion process from one unit to another, and to avoid writing extremely large or extremely small numbers. It also simplifies how it is divided into smaller units. Instead of dividing into some obscure number, such as 5,280 feet in 1 mile, each individual unit is divided into 10 smaller units. And each of those smaller units is divided into 10 even smaller units, which are divided into 10 even smaller units, and so on. Each division is based on powers of 10, which makes conversion from one to another much easier. The basic units in the metric system are given in this table, which is from your book. The meter is the unit for length, the kilogram for mass, the second for time, the ampere for electric current, the Kelvin for temperature, the mole for quantity, and the candela for luminous intensity. All other units used in physical science are based on these 7 units. Now here we will focus on quite a few of these, perhaps not all in this course, but we'll see most of these throughout the course. Now the beauty of the metric system is that I can talk about one unit, and then I can just use a prefix to describe large values of that one unit, or a different prefix to describe small fractions of that same unit. If I want to describe a large amount, I can say hecto instead of 100, kilo instead of 1,000, mega instead of 1,000,000, and giga instead of 1 billion. For smaller units, I can use deci to mean 1/10, centi for 100th, milli for 1,000th, micro for 1,000,000th, and nano for 1 billionth. Simple example, if I want to say 1,000 meters, I can simplify that to say 1 kilometer, as indicated here. Now, I can also use this whole metric system with other measurements as well, such as the gram. In this case, all I had to do was change the base unit from the meter to the gram, and all the prefixes remain exactly the same, as do the conversions. Let's see how easy it is to convert from one unit to another in the metric system. Recall from the last slide that we said that 1 gram is equal to 1,000 milligrams. Now, let's say that we start off with an amount of 25.4 milligrams, but we want to know how many grams this actually is. To do this, all we have to do is multiply by a fraction. Take the unit you currently have, which is milligrams, put it on the bottom, and put the unit you want on the top. Now we already know how many milligrams are in a gram. And so from our relationship up here, we know that 1 gram is equal to 1,000 milligrams. This way, the milligrams will cancel each other out, and then all we're left with is 25.4 grams divided by 1,000, which would be 0.0254 grams. And you're done. Okay, let's take another example. Let's say that we have 1,256,000,000 meters. You can see how obnoxious it would be to have to say 1,256,000,000 and so on if there are more digits after that. If you have to do that repeatedly, it gets very, very difficult. So what we're going to do is take this number and translate it into a metric prefix. Now, since we're dealing with a billion, recall that 1 billion meters from our chart before would be 1 gigameter, because giga means 1 billion. So we want to convert, since this is in billions, we want to convert from meters to gigameters. From this relationship, we know 1 gigameter is equal to 1 billion meters. So 1,256,000,000 meters divided by 1 billion meters cancel. We are left with 1.256 gigameters. Much easier to write it this way than to write 1,256,000,000. So the bottom line is this. The metric system is a much simpler system for measuring, well, anything. In the scientific community, we always use the metric system. In most countries, in fact, the metric system has become the standard. Even here in the United States, the metric system is an officially recognized system of measurement, even though we tend to stick with the English system using feet and miles and gallons, so on. So be familiar with the metric system, as it is what you will be using not only throughout this course, but throughout the rest of your life.